Mhm. Come on, come on, YouTube. Okay, cool. I think we're live. Welcome, welcome everyone to another session um, of Node.js and AWS Rolling Scopes School Program. And today we have the following agenda. You can find it in the description of our stream. And the agenda is the following. Last module theory overview. I want to make sure that you all know and understand well what was required from you, what were the key points or the key takeaways from theory of module 3. Then we'll do, as usual with our Q&A sessions, after cross-check, we'll do a cross-check code review. I've picked up some of the random pull requests that were made by people. I try to be um, kind of not influenced by anything other than the actual scoring that those people got, trying to review um, someone who got a high score, a medium, and someone who got some of the scores taken by various issues with their code base. I'm not going to reveal which one of those people have what scores during the live stream. However, I'm going to go through the code as I was the one who was reviewing the code myself. And then we'll conclude the session first with a current module theory so that you have a better understanding again what to focus on during your self-study and on the Q&A uh, kind of session Q&A for anyone who joining the stream or from Discord. Okay, so let's go to our module 3. Module 3 was named by the word serverless, and this is the main focus of this module. It's all about building some kind of API. In my opinion, the first and foremost is to know what is serverless, and this is one of the goals. So understanding that serverless is not just a bunch of Lambda functions connected to an API gateway. Then explore what are those different AWS services like AWS Lambda, again API gateway, why we're connecting them together, and at the same time learning some of the stuff that is considered serverless in AWS ecosystem. And then finally, the goal of this module was to introduce some kind of an API to our already existing front-end application with the help of AWS Lambda and API Gateway as a front-end solution. So, um, just from my own perspective, the main thing to understand about serverless is not about serverless things. Uh, Only like Lambda functions and services such as API Gateway. Serverless as a concept focuses on having no kind of maintenance requirement of your infrastructure in terms of OS choice, container choice, different libraries inside of those containers, apart from what your own code requires. So, giving that, serverless could be considered anything that is a service that you can launch as a part of your architecture. However, which at the same time are not maintained by you. So if you remember the first module that we had as a part of this program, Cloud Introduction, we introduced several different concepts, such as serverless models, cloud deployment models, etc., etc. And exactly in cloud service models, we discussed infrastructure as a service, platform as a service, software as a service, and last but not least, we touched on function as a service. And that last bit, function as a service, is one of the main driver force for serverless becoming a thing nowadays. And it's all about giving your cloud provider a raw code that you want to run and specifying that, hey, I want to have these and that resources without like particularly caring how and when those resources will be provided. So that's kind of a maintenance of AWS or responsibility of AWS. So coming from that separation of services that cloud provides, serverless is um, kind of cutting through the service models and introducing a more kind of focused look on whether you're managing something or whether you're not managing something. And coming to AWS Console, for example, if you look at all the services, um, some of them will be managed by you again, and some of them would be managed by AWS to some extent. And if you go through each one of the categories, you will stumble upon services that particularly say like EC2 being managed by AWS itself, and then Lambda as being kind of the same compute resource in AWS not being managed by you at all. That's one comparison that you can make. Um, Also with, for example, containers, if you're familiar with containers as a service, we know that there is a elastic container service, which internally can be considered serverless and not serverless. So it provides two kind of modes of running stuff. So if you look at the definitions of those clusters, when creating a cluster, you either choosing to manage the cluster yourself when you click on it. Let's see, configure cluster, yeah, network only, blah, blah, blah. At some point, you will see something like AWS Fargate, which says like, hey, you can use AWS Fargate. So let's proceed with that. And yeah, so once you go through creation of your own cluster, you would be essentially launching a bunch of EC2 instances if you choose like management of resources yourself, circling back to the question of computes with EC2, or using Fargate solution, AWS Fargate, which is under the hood using a serverless mode of running containers. And same can be said for various different resources. For example, the upcoming resource that you're going to be adding to your architecture, which is a database solution, it is also could be either managed by you or completely managed by AWS to various degrees again. So if you think about it, one of the services that you might be familiar with is an RDS, AWS RDS, and their RDS instances that are like managed solution. So you will be managing those things to some extent. Um, and con uh, compared that to something like a DynamoDB, which is again managed solution, but already managed by AWS. In terms of if you want to have access to its internals, for example, to know exactly on which machine it's running or exactly what type of um, operating system it's running on, you won't be able to do that. With RDS, I want to mention it is possible to some extent to choose what are the instances will be running your stuff, but again, you kind of abstract it away from that. Like again, if you know theory behind databases, they're essentially virtual servers specifically configured to run databases and databases only. So you can imagine that those RDS databases, SQL type of database solution, could be as easily replicated with some responsibility shifted to you as a maintainer, with a bunch of EC2 instances bundled in such a way to like hold those Postgres databases. So again, coming to RDS, you at some point you will be kind of faced with a choice of choosing a managed solution or kind of completely unmanaged with various different database engines. For example, a well-known serverless agent or engine, sorry, is an Amazon Aurora, which essentially has a proprietary solution for that. But yeah, again, that's going too much into the next module. But yeah, understand that serverless is not only about AWS Lambda, but for anything that is not managed to the OS and like machine level by you as a developer. And that includes something that we'll be covering in later modules. And for example, yeah, it's very hard to find something in here. I think that might be integration management, integration development. Okay, yeah, that's just SQS, for example. So some SQS, some solutions like queuing services that are like basically handled outside of cloud with something like Kafka or RabbitMQ, uh, or things like SNS, simple notification services again. They're all managed, so you can imagine that when you see managed solution, in most of the cases, with AWS, that would be something that you're not managing at all. So you can essentially build a completely serverless solution with those services, meaning that you just provide code that basically encapsulates your own business logic, and the rest is handled by you, all the ups and downs. You don't manage anything. So that is essentially what serverless is all about. Coming to, let me just close RDS here. Coming to the next topic that you kind of need to understand is the relationship between Lambda service and a API gateway service. So again, exploring a bit our management console. Let's go to Lambda. Um, okay, okay. It immediately says run code without thinking about service, and that is true. Um, mm, what it is going on with Lambda? It's not some kind of magic. You know some theory behind it. In short, whenever you create a Lambda function, there is, or like with the case of any serverless and like service, essentially anywhere in the cloud, uh, there is still a physical resource that is running some kind of OS, that is running some kind of containerized solution for you, and your code, in the case of Lambda function, just ends up in one of those containers, completely isolated from any other things. So there might be physically one machine, but a bunch of different services running on it, a bunch of different functions running at the same time, all isolated or using some kind of containerization solution. And this is like essential to understand because AWS Lambda is able to execute your code whenever you need to. But again, this is not some kind of magic. Um, like this convenience of not caring about what is underneath your function comes with several drawbacks. One of the major ones is the fact that whenever you're not using AWS function, it is not working. There is nothing. It's just kind of it's shut down basically, not terminated per se, but shut down and maybe shifted, like those resources that are running your AWS function typically are shifted towards other clients. So you basically that means you're not paying much for it. However, once you have requests coming in, no matter their nature, be it like API gateway or some kind of notification from other services, not necessarily HTTP based again, any event that triggers your AWS Lambda would require that infrastructure that you kind of abstracted away from would require that infrastructure to spend some time spinning up those resources for you, um, spinning those OS and containerization solution, then grabbing your code, putting it in there, running all those, in our case, npm installs inside, and then, only then, executing a function. So there is a delay. So that is the major thing to understand about Lambda. And the second thing is that um, it is essentially um, event-based thing. So it's not necessarily should be a HTTP-based solution. AWS Lambda and AWS Cloud solves various different problems or fits various different problem domains. Whenever you need any code to execute any reaction to some events. Lambda is a perfect customizable solution to that. And this is again the major thing to understand. AWS Lambda is not only about API gateway, but any automation per se. There could be an S3 bucket event, and you can hook up your AWS Lambda to listen to that event. There could be a CloudFormation event, or like anything in your pipeline if you are brave enough to handle stuff using AWS Lambda within your pipeline and not going for EC2 instance-based pipelines. So in your CI/CD. So anything, any event, even the CloudWatch events, which is a famous use case for Lambda functions. For example, grabbing an event or reacting to an event in your logs, CloudWatch logs coming from whenever or wherever, and I don't know, analyzing those logs and putting in them outside to the internet, maybe to a remote aggregation solution. This is a perfect use case for AWS Lambda. So any automation usually has an AWS Lambda somewhere underneath. And lastly, yeah, AWS Lambda is a resource. You care about only its like power uh, or like physical resources, meaning like a CPU and RAM. If you specify that, AWS will be able to accommodate again. And if you want to, you can have limitless scalability. That's like one last thing to remember is that since it is kind of code or user agnostic and it's technically in the cloud waiting for anyone to be using it, and if someone is not using they're not paying for it. So since they have like AWS Lambda is created to have these features. It is essentially limitless in terms of scalability. So whenever, like technically again, whenever you have a high load, for example, for your API, and if your one Lambda function is not able to accommodate that load, there will be another version of the same function spun up within a separate container that will be able to handle that load. So without going into too much details here, this 3 points are major things for you to understand, and you can build up on this knowledge if you so choose to. And I'm sure that in the program you'll have plenty of opportunity to do that. And coming to our last service in question here, let's go look at the gateway. Oh, come on, AWS. So build, deploy, and manage APIs. Gateway as a word has a very unique application and a unique ring to it in architecture in general, and it stands for something that is fronting a larger system. So that's why it is called gateway, not just Amazon API. So being a gateway, and in order for it to be flexible, Amazon had to come up with something that is um, moldable, basically, that they can provide as a service for people to um, kind of change modules between each other and um, connect them in a way that they see should be the case for their like particular use case. Pardon the pun. And I know that some of you were asking like what are the differences between all those different API types, etc., etc. And essentially, API Gateway as a service um, cares only about um, the incoming messages and the outgoing messages, or I should say integrations in their words. So incoming integrations and outgoing integrations. What I mean by incoming integration, API Gateway as a service could be made to listen to various different incoming requests um, in a different ways possible. So we can already see that it's not only HTTP API, it's also a WebSocket API with all the um, kind of outcomes that a WebSockets API brings. So keeping connection live and not like having that real-time communication. So API Gateway as a service needs to be able to do that. So it's not just an express service that just listens to requests that we are so accustomed to. Again, they have also REST API and HTTP APIs that have some differences. HTTP API being like least I should say least kind of biased towards any particular architecture, and REST being the one that does some management for you essentially without you needing to maintain those things. And then again, the 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 integrations that are behind API gateways are also different among those services. So essentially, what we're saying here, API gateway as a service could be listening for various different requests, then do something with those requests, transform them in a way, and then um, send the resulting requests, the transformed request to various different backends, be it like a Lambda function in our case, so it's a Lambda function, or another HTTP backend, so another HTTP service or server that listens to those requests, so that's also possible, or even in the case of our REST APIs, that could be also transformed into an event, and that event could be uh, used um, as a way to trigger some kind of AWS service that is not necessarily an API per se. So an example would be API gateway triggering an SNS topic, for example, or SQS messaging queue. They are not per se APIs, so that's where the difference lies. So as you can see, that some of the pre-managed with REST API compared to just a typical HTTP API is done for you. So that is the major difference. So what are the things that I um, kind of wanted for you to remember? First is, yeah, there are different API types, and they're different by um, what are the incoming integration um, that you have and what are the outgoing integrations. So based on that, you will be able to choose the API type. Then we also have APIs themselves. So let's build one real quick. Yeah, so you'll be able to choose your integrations. Should I be creating something like an import? Can I import something that is already? Okay, yeah, I need to specify that, sadly. Let's create it real quick. So API gateway temp API. Let's let me review and create integration, no roots, etc., etc. What about this one? Um, uses roots. Okay, what about integrations? Let's see, let's have an HTTP. Okay, I need to provide an actual HTTP request, Lambda. Again, some kind of Lambda integration is required. Oh, damn. Let's have google.com slash, will that work? Uh, okay, cool. Next, create. Hopefully that is enough for us to kind of demo stuff. Okay, so whenever you create an API, an API would be an object in common sense. So that being said, you will be managing it as an object in your serverless framework or CloudFormation, essentially. And you can consider different techniques that are able for you to manage. So whenever you think about Express APIs, you think in terms of endpoints, essentially. So there is different endpoints and there is a server that has those endpoints. So if you think about API gateway is like it's more like your endpoints would be actual lambdas and like their corresponding strings would be inside of your API gateway, and your API gateway would be essentially that object like server, you can say, that is kind of encapsulates all those roots and connected lambdas to them. So there is a close comparison between the two. So whenever you have an API, you will be able to create some roots, choosing verbs, etc., etc. And when you have those roots, whenever you click on them, you will be able to do whatever you do with your roots in Express API before going into too much of the business logic. So roots in Express API will require some kind of validation, authorization, etc., etc. So, and just passing those like middlewares and Express case would result into an actual controller being triggered. In our case, an actual control would be a Lambda function. But anyway, coming back to our integrations, again, authorization could be handled for various different cases. If you remember your Express API theory, a typical middleware that handles authorization is nothing more than just a special function, essentially. That is also the case for your API. So if you wanted to have a custom authorization without using um, services, essentially, so authorizers, IAM, etc., etc., or Cognito authorizer, you will be able to create a separate Lambda function that handles exactly that. As you can see, so there is like this connection. So that is that. And then coming all the way to API itself, let's go to integrations. Hopefully we'll be able to have those integrations. Yeah, so integrations, as I said, are the things that are standing as outgoing destinations for your APIs. So whenever an API comes to this, API request comes to this particular combination of verb and a root, going through various transformations, it would end up sending some kind of request or event to various different destinations, either HTTP URL to transfer to some kind of Express API, for example, or a Lambda function in our case, or even a simple queue service, event bridge, step function, anything that you can think of. So if I were to send it forward with some kind of, I don't know, um, let's just bother google.com/tests, whatever. Let's to out. Let's do that. And then it should be a GET request with some description. We'll omit that. And essentially, this is our integration. Um, if you think about integration as just destinations, you would be very close to the truth. However, your integration can be part of a larger API gateway-based transformation process of incoming requests. So, all in all, API gateway is the place where you manage your requests as if you were doing that in your Express server. With that, you will be able to map using custom mapping. For example, mapping requires body to some kind of requests path parameters that are outgoing. So transforming in a way the incoming requests format to some different format in the outgoing. So you can already feel that the major thing to understand is that API gateway is the service that you're not only using as your API as basically a backend for front end for your actual front end listening to requests coming from your client, but it could be kind of created and used anywhere in your architecture where you need that mapping or remapping, some kind of authorization. So this is a service that is pluggable. As AWS Lambda that we already saw is pluggable whenever you need actual scripting automation per se. And API Gateway is similarly a service that you can plug whenever you need that remapping or like forwarding of those requests or additional authorization of requests. And that is the essentially what you need to know in order to kind of completely grasp API Gateway going forward. Um, we will have separate kind of things talking about CloudWatch going forward. At this point, you just need to know that CloudWatch is essentially the place where your logs are kept whenever the log source is. Um, for example, Lambda requests could be logged, Lambda responses could be logged at the same time. If you think about it, API Gateway internally as your if you think about API gateways as analogous to your Express routes, you know that Express routes might have logging implemented as middlewares, logging the requests themselves, not necessarily custom ones that you like manually or imperatively call throughout your code. Those logs, those route and request response logs, could be also accessed in API Gateway, though you need to pay separately for them. And they also end up in CloudWatch at some point. So if you are interested in whether you are able to log requests coming into API Gateway without any that transformation happening behind the scenes, yeah, you will be able to do that. Let me even try to find the exact location where we'll be able to configure them. Let me see if I can do that quickly. They're updating the management console UI, and it's sometimes hard to keep track of where things are essentially. Stage could be stage, stage variables. Okay. And yeah, last thing, yeah, before let's drop the logging because it's yeah, oh yeah, it's here. Before going into too much of those details, there is a concept of stage that you need to be aware of, and stage is kind of an instance of your API. You can think of your API gateway as a class in those classic OOP sense in other languages. And stage being the actual deployed version or instantiated version. So you could do versioning with that stage. You can do different environments with several different levels of authorization for different ones. So, for example, a stage for your UIT environment, or a stage for your um, pre-production environment, or the actual production. So all those environment type of things in classical sense in the case of API, Gate, and Lambda as serverless things, could be handled in stages and Lambda versions. That's one of the things to kind of be aware of. Okay, I don't think I'm able to. Okay, access logging is disabled. So yeah, those access logs are exactly what you need to look into when you want to have that root level logs available to you without any logic applied. But again, they are paid things because they have a very different format from what we used to seeing. So yeah, they're disabled by default. Okay, so at this point, kind of okay going forward. Let me check what would be the third integration with database. Cool, amazing. Um, let's see if we have any questions. So at the moment, okay, so seems like we don't have any questions. That is cool. I think I might be doing something good with these lectures, so that they are actually useful. Okay, and before going into database, let's spend some time looking through um, code that people wrote um, as a cross-check pull request flow. And we'll start first with this person. So as usual, um, as the one doing a code review, I would be looking for a detailed description, which is helpful, and a kind of sense of courtesy for those people who check code. This person did an amazing job just by looks of it. So um, from looking at the description, I have immediately a link to the actual task, the deadline, and when the task was actually done, um, which is testable by the commits if we so choose to. Let's see, yes, June 9th, so it's even earlier than the deadline itself specified here. So the score, okay, 11 out of 11, front end, uh, pull request, backend pull request, I think, backend API link, which is, from the looks of it, is an actual link to API gateway, which is cool, query. Also, we have an automatically, I assume, automatically created Swagger documentation. Let's try accessing that. Um, Interesting to look at. Okay, cool. So Swagger is implemented, which some of you may have asked, like, is it necessarily? It is not. However, if you go through your API gateway, you will essentially stumble upon some kind of open API definition or a way to create an actual API gateway instance using API definition, open API definition that you already have. So use case would be an Express server not native to cloud, essentially, uh, that is maintaining some kind of open API 3 documentation or Swagger documentation. You grab that thing, you upload it to API Gateway as a way to create an API from that documentation, and you end up with a beautiful API with just small configuration changes that you uh, need to apply in order for it to work properly. However, this person went and did a nice job of creating Swagger documentation, which is cool. That's very convenient for me. Let's see if I can actually run anything. Valid, try it out. Can we try something out? Okay, so let's execute curl one. Okay, so we get something return, which is cool. I can see the response kind of format. Amazing, exactly what we need to. Let's have a look at okay, I think it's the second one. Amazing. So API is live and working, and I can see that those curls are successful. I can also try doing that from my console. Let's run that. Okay, and I think we're getting something. So that is essentially saying that there is actually an API going on and it is live, which is amazing. Okay, and we have a front-end pull request going on and the backend. In this particular module, we're more interested in backend, so let's skip that and go to the code itself. And skipping some of the stuff that is not related to the actual code or AWS per se, we have, okay, get product by ID Lambda and get product list Lambda, okay. Then some mocks, so assume the ones that are used behind the scenes, since we don't have a database solution yet. And then some of the package JSON stuff, Swagger init py, yeah, uploaded Swagger definition, some tests, amazing. Okay, and the actual service that we're using to upload it to AWS. Cool. So once I get the sense of the actual code that we have, I will be able to go deep into um, code definition. So let's see. So by the looks of it, this this folder contains just those Lambda functions. Okay, cool. Let's find serverless YAML file. So I think that's deletions, just deletions. Okay. So that raises a question, where are the actual serverless files that handle those functions? Let's check the code here, master branch products, serverless YAML. Okay, so it wasn't changed. Let's look at the thing. So it is just a typical serverless function that is connected with event to AWS API gateway, um, which is in serverless framework is enough to have that event API gateway to be created. And since that is I assume that is the same API gateway, so it's just an endpoint definition for those functions. Okay, cool. So now that I know from the perspective of infrastructure what's going on, let's go deeper into the code itself, and I'm interested in the actual code. So I tested out Swagger definition for get product ID. That is cool. Let's see the code itself. So we are handling course issues with this type of thing, which is amazing. So we're allowing some origins, so specifying headers, and I assume those headers would be used as a response somewhere in the code. Okay, so various levels of nesting, which is not per se a very good approach to do that. And at the same time, I see some less, maybe a personal choice of this pull request creator, but since I'm not 100% sure that this variable changes somewhere down the line, down the code, I would do that just using const. Then if we have something returned from a products filter, which is filtering out, filtering out by ID. Okay, cool. And grabbing the first, which I assume just a byproduct of how we handle mocks. Let's see, mocks are just an array. Okay, so essentially what we're doing here, we're reducing that array with a filter function to contain just one item, uh, which with a corresponding ID. Cool. Okay. And yeah, if we found anything, if we found that item or by ID 0, we respond with the actual response. Okay, we're creating response object. Cool. We're providing those course headers. We're doing some of the stuff that API Gateway needs to kind of forces us to have, which is an encoding and status code. Otherwise, you will have errors in API Gateway. Cool. And then we're stringifying the result. Also cool. And yeah, otherwise we're responding with an error saying we didn't find anything, or even 500 if we failed somewhere, which in this case might be this function that that is actually throwing an error, and we're catching that error with a try catch, resulting in a 500. Cool. That is essentially cool. My only issue maybe would be mm, 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 if we're using async await, where we're kind of okay, we're marking it as that we're using await. Um, So going forward, my suggestion, looking at the code, which is a correct code again, is maybe look into how we can get rid of callbacks and instead, with additional wrapping, end up just returning some response. So it's a very typical way to do that when working with lambdas, creating some kind of a wrapper function, like a decorator type of thing or high order function type of thing that handles those course headers for us there and handles creating a particular format of those objects for the use of API Gateway for us to not repeat ourselves. Because I assume if I go to the next function, yeah, we will have the same issue here, basically forming again and again, repeating the same status codes and repeating the same headers, even having a different format. So this should be reusable within those Lambda functions. Okay, cool. So for this person, would the only recommendation would be to look into those higher order functions to kind of get rid of repetition of headers and control how we do that. And again, get rid of callback handling of code within Lambda function itself. Think about if we find something, we return that response, or basically find the filtered product. It will be injected into the body and stringify there. If not, we'll return a different object. That could be the case. And this 500 error could be even handled outside of Lambda function itself in that decorator with a try catch. So you will end up with a very concise code if you go that route. Okay, cool. So it seems like everything is working. We already kind of did the code review and we tried out the code. And essentially, hopefully, everything else, the front end part, is actually live and working. Let's just quickly check that. Okay, so this is just this is the branch. I assume that it is already merged or the pull request is opened. Cool, let's check here. So the pull request has almost the same content as before. Let's check files changed. Okay, so what are we using in terms of code? Okay, React. Let's check the code serverless. Does it have It shouldn't have much changes in terms of um, the variety of services that we're using. We just have okay, changes in buckets, deletion of comments, which is cool. Thank you for that. Addressing this whole thing. Allow call front access identity. So I think that's regarding the S3 bucket. Yeah, bucket policy. Okay, cool. Makes sense. Allowing different methods. What are we doing here? Is it so? Okay, so it's a cloud front distribution. Okay, nothing in particular in terms of how we do that. Let's find exactly where we call those functions to kind of be able to um, close the loop, so to say. So I assume it would be somewhere in products, and we're using use effect to just directly make access.get request, and then okay, cool. Um, some of the code, if you would like to do like a proper code review, might be commented on. So apart from just checking how things are working, we might give additional advice on how it's better to handle different stuff. And I'd say that creating a wrapper module, a more kind of high level module to handle all those requests would be a way to go. Additional, so that we don't have any like specific things in our components per se, and we can reuse across the code base. Then next thing, since we're using async await in our backend, and this is a way to go if you want to be modern. I would go with the same when it comes to making access get requests. You would need to do additional configuration with your use effects to handle async await, but again, it should be done in terms of consistency. Then mapping and JSX, it's not the way to go. I would extract that into two separate functions essentially. One function would hold everything inside the callback of a map function, and the mapping would happen in a separate um, function as well, so that the only thing left on this line and for the rest of the JSX here would be just a call to some function that essentially would be returning whatever I need to have in JSX. That would increase actual readability of your code and extensibility. So you would be able to focus on the exact items that you want to see in your JSX without like having weird indentation and map obstructing your way. So think about going into two functions presumably. Okay, so the rest, yeah, keeping API paths separately is a very good idea. I would say um, maybe to kind of abstract away another level, have additional abstraction of in terms of base URL would be nice to avoid this repetition over and over again. Okay, so models, yeah, this is just a type. Okay, cool. So looks good, works as we checked. Let's just finally check the actual um, bum 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 actual deployment to see how it works. See if we're seeing those requests or not. Yeah, depending on if we are working with live um, integration already. So, okay. Okay, so just by looks of it, since it's not okay, I think they're coming from the actual backend. Do we have any ability to go inside? I don't think so. That would be cool to add. Okay, well, we're doing a request to a card, which is nice. Okay, so I don't see how I can get a particular product. Um, oh, let's see. ID one, maybe something like product one would result in correct thing. Okay, no, just an error page. Okay, cool. So this is an example of how would I address, how would I go about reviewing someone else's code. Fortunately, given the fact that I spent some time explaining our previous module, making sure that you know about AWS Lambda and API Gateway, we don't have any more time to do that. But this is a really nice pull request. Um, again, you can look into the code. I showed you an example of what I look for when I'm doing a pull request and what are the steps that I can take. You can replicate that in order for you to address one of the next topics and during cross-check, which is a integration with database. So just by the fact how we're building this program, I would assume that the pull request that this person has created with mocks would then use an actual database to hold the data. And if we look into the implementation, it would not be importing products as is. So this would change to, I don't know, maybe import uh, appropriate database solution, and then this line would be changed to access the actual database service. So this is the expectation, but the rest, the Swagger configuration should be able to respond with the same data, presumably, if we are successfully implementing the whole thing. So what do you need to know about databases in AWS? I've touched on that thing already a couple of times, but databases in AWS could be divided roughly in several different categories, but you need to know one, relational databases that are handled by RDS mainly. Then, a second most popular database solution within AWS is a DynamoDB, which is a NoSQL, or a more correct way to say key value pair storage. What are the differences? Again, NoSQL versus SQL. This is the most important thing for you to look into, given that. Then I would suggest to look into what are the other types of databases out there. Uh, Essentially to address the topic of why am I calling DynamoDB not necessarily a NoSQL solution per se, but a key value storage. So you would need to have a at least rough understanding of that there are different types of databases within relational category, within NoSQL category, um, that some of those databases could be um, called like transactional databases, some might hold analytical data, and those analytical data is is usually handled in a different way. You cannot per se use a just an RDS instance for that or a DynamoDB instance. So different types of data require different flavors of databases. For example, a Facebook a group of friends in terms of the technical implementation of that group of friends, grouping of people, is usually a graph database. So again, kind of have a rough understanding of um, that NoSQL and SQL are not the only types of databases that there are. This will help you to understand why we have so many entries in here. Why, when we have an RDS, we might be talking about some kind of analytical stuff, or even if we go into more mm, kind of details, why we have, for example, an S3 service kind of appear when we talk about databases with its analytical abilities or data lake abilities. So you need to have that understanding. Then um, understanding of key value storages. How is it different from just NoSQL? The service that we are kind of touching separately is a MongoDB instance that AWS provides you with a Amazon document DB. So you need to understand, at least know about this type of databases. And then classical key value storage in memory caching, as we have with um, yeah, Elastic Cache or Memcached as a more traditional like flavor, and one of the types of engines behind Elastic Cache. So yeah, have a grasp of different flavors of databases. Then coming into concepts behind databases, you need to be able to tell the difference between an a like the languages or the definitions that we use to um, connect to or like talk to databases. You would need to understand what is a ORAM or object relational mapping, an ODM, object database mapping, how that mapping will be used in our pull requests to handle those databases that we import, because you might have various different ways that you can approach making requests to your database. In our case, that would be an RDS database. So RDS being a relational database, um, is backed by various different SQL flavors or engines. They have different SQL versions of languages that they are using to kind of talk um, or like process data. So you need to have a solid understanding of when you need to write an SQL query directly, what are the options of not writing an SQL query directly, how OREM kind of solves that issue of writing an SQL query directly in your code. And then, yeah, have an understanding of how SQL language helps you to at the same time create databases or manipulate databases and then manipulate data within those databases. So SQL flavors type of thing is also a thing to remember. Going forward with RDS, the um, kind of one of the major things that you will go through when you have an RDS instance is um, whether it's a serverless or not serverless solution, or why do we need to use RDS service to do databases in AWS Cloud instead of just using EC2. We kind of touched on it, so make sure you understand pros and cons of creating an EC2 instance, installing your favorite flavor of database there, patching it correctly, uh, launching it or initializing it, making sure that requests are coming through to your EC2 instance. And yeah, so make sure that you understand what are those options compared to what RDS as a service provides you with. And finally, how can you go about not caring even about resources behind RDS? Because whenever you create an RDS instance, at some point you will be asked to choose and the flavor with this type of selection. Then you would actually need to provide some credentials, and that's typical, but most importantly, you would have to provide an instance configuration for that, then storage allocated there. So under the hood, it will result in a different EC2 instance configuration with an EBS volume handling your data. So coming from that, you would need to have a solid understanding how can you just get rid of everything like that headache going for Amazon Aurora serverless distribution. So um, have a solid understanding why we have that serverless thing there and with RDS instances. Um, in- and I think that would be enough for you to kind of go forward. So let's see if I'm able to find serverless configuration here so that you understand what I'm talking about. Um, Memory optimized. Can I have just a serverless? I completely forgot why I need to have that serverless thing enabled. But yeah, just make sure that you understand how to go about creating seemingly SQL database that requires an actual instance to manage, um, but going completely serverless and scaling it up and down whenever you need to. Okay, so and at this point, I think you will be you will have enough understanding of what your focus should be, and I wish you good luck with your tasks going forward. And yeah, see you next time, I guess. Bye, guys.